so my name is Brett Butler, and this is my brother-in-law, Taylor Gabriel. And what we're going to be going over is Lab 3 that we did for our program. And so, just starting off, our objective is going to be to create a program that sorts a list, we can also just call an array, in ascending order by the number of quantity for each produce item. So what this means, the theme for this lab is, say you're working in a grocery store, and you have like produce, which we might say, just for example, maybe apples, and we're going to assign a quantity to that. What this would look like in computer language is, say, like we have a 16-bit or a 16-digit number. We can say that. That's going to be composed of just ones and zeros. So conventionally, we're going to start actually at 0, and then we count left hand all the way to 15. That's going to make our 16 bits. And what's important about this lab, what we really care about, is the quantity. That's how we're going to be sorting things in ascending order. So our quantity is going to be represented by bits 8 through 15. That's what we're going to care most about. And then whatever produce it is just going to be represented by this number over here. Now I want to emphasize that this is just one number as a whole. It's going to take up one space in memory. We can also just visualize this as just one place in a line. So think of like a line of people. This is going to be like one person in that line. Another way we can think of this is over here. So we have like an image. This is what memory might say look like in a computer. We can think of this as like a row of mailboxes. And for each mailbox, we're going to have an address. So we're going to call this, it's not X 4000, but Hex 4000. And it's just going to go down from here, Hex 4001, Hex 4002. It just goes all the way down, and that's going to be like what our list is in memory. And in each mailbox, we're going to have this 16-bit number. So each one of these numbers is going to go in one of these spaces, and that's what's going to complete our list. So this is what the flowchart is going to look like for the program. But I kind of have like a simplified version of just kind of like the steps that we're going to go through for the program. The first thing that we're going to do is we're going to load so-called pointers, which is going to help us look at the two different quantities that we're going to be comparing. So we're going to look at like apples, the next one's going to be oranges. And what we're going to do is load these quantities to what we call registers in computers, and that's going to be like holding spaces for these values. And so that's kind of like what we're doing right here. We're loading our pointers into register 0, register 1. And then first thing we're going to check, we're going to see, okay, are these quantities, is it 0? If it is 0, then we know that our list is empty and there's no work, there's no sorting to be done. So that's just initially, we're just going to check that. Most of the cases, there's going to be work to be done. So we'll just continue on to step 3. And we're going to need to rotate our number. And what I mean by that is in this bit 8 through 15 is going to be our quantity value. That's really what we're going to be referencing in order to get into the ascending order. And so we need to give each of these values, so we're going to bump it, and it's going to come all the way up to here, this first one, and it's kind of going to do like, I don't know, like a domino somewhat of effect. So then this one's going to come all the way over, and it's just going to do bumping, bumping, bumping. And so this whole number is shifted over here. So it's just this shift to do our compare analysis. That's just the way the computer's going to work. And so here's another visualization. So whenever we move on to step 4 and we need to compare, it might look something like this, right? We have one quantity or two quantities. We know that's in ascending order. That should be great. What does that look like in math? 2 minus 1 equals 1. We know 1 is going to be greater than 0, so there's no need to switch. But if we have 2 first, and then we have 1, we know that's not in ascending order, and so therefore the outcome should be negative if we were to subtract 2 from 1. And so this would call for a switch. And I'll go into more detail what that looks like in our code. But, so we're going to figure that out in our code, just whether there's a need to switch or not. And then we have a whole list. So this was just the first 2 values, apples and oranges. We have bananas, we have whatever, all the lists to go through. So how are we going to do that? We're going to increment our pointers. And so what that may look like here, I'll zoom in a little bit, is we'll have one pointer and a second pointer. After these first steps, we're going to increment the second pointer down 1 space. Then we're going to compare that. We're going to go through steps through 5 again. And we're going to repeat, or we're going to increment this pointer all the way until we just have hex 0, 0, 0. Which means we're done. We've gone through the list. Now we need to increment the first pointer. So we're going to go through the whole process all over again. The same, now it steps, essentially, 3 through 5, until our first pointer right here is going to be x, or 0 to 0, which signals we're done. We've done all the sorting and everything is in ascending order. And so what this would then look like in our code, so now we're speaking the computer language. If you see LD, that does stand for load, so it's going from memory to registers. Like I said, registers are those holding spaces the computer uses. Or you might see something like ST or STR, that's going to be going from registers to memory. It's just going to be the reverse of that. And you might see other things such as BR, which would be branching, to different lines of codes, and you might see BRZ, which that's a conditional branch. So if our value that we're checking is a 0, we'll then take this route. We'll go to swap, which is right here. So just going back to the first line of code, this is just us loading our pointers. Pretty easy, so we're just pointing to our two values that we're going to compare. And then we'll be going off that. So block 2 is just going to be the mass of our code. Something that's really emphasized here is this JSR, compare. That's going to stand for a subroutine. So because we'll be comparing these two values over and over again, we don't want to write the code over and over again. We just want to essentially have a loop or a repeat. And so JSR compare will do that for us. We only have to write it once, and we'll just do it over and over and over again. And within our JSR, so this is our subroutine right here. Within this is where we're going to do that rotation of the bits as well. It's going to be embedded in here. And then, we just keep track of our pointers to see whenever we've hit the end of the list. And I also like to point out this RET, this return will return us back to where we left off on the subroutine. So for example, it would take us back to JSR compare, but we're going to go down one. So we'll be at this add function. And so pretty cool. So now I just want to show you what this might look like in terms of like code. So I'm going to go to hex 4000 in our memory, and I'm going to go ahead and we'll put a null. So this is going to be the end of our list right here. So what we should see whenever we run the code is that all these numbers, so we're starting at 1, it should be in ascending order. So essentially this 0, 2 should come all the way to the top and then just be like x 1, 5. Remember, because we're just looking at these first two values. So I'm going to go ahead and press play and let's see what we get. Cool. Okay, so now we see that we're starting at 0 and we're going to go up to 1. We'll see something 1. We just look at the first values and you see 9. And then C, E, C is going to represent basically the digit number 12, and then E is going to be 14, and so we just see that it is in ascending order, so then our produce will then be complete. So, and then again, ending with hex 0 to 0, signals the end of our list. So, that is our lab 3. Thank you.